Hello, I created this channel to discuss reverse engineering some drone data, and I'm using Skydroid MX330T. I got this drone because I wanted a drone with a dual sensor with a thermal on it, and this one's pretty good. It's a 384. It's not a high resolution, but it's a decent one for my purposes, and it has a 2K camera on it as well. And I really like the G12 controller, and you can toggle between thermal vision. What did I do? You can toggle between thermal, which right now it's very blurry, same at my bench. So I like the G12, but with the MX330T, I've crashed it a few times right away. I've never flown a drone before, and I noticed right away that I burned up MOSFETs very easy. And I designed motor controller systems, and a lot of what you see on my bench is motor control systems. I design automation systems. So I thought, why don't I see if I can come up with a solution to burning up the MOSFETs on this board, which are inside of here. Here's a burnt up board, the first one that I burnt up. The MOSFETs pop, and sometimes you can repair them and sometimes you can't. Like popping off the MOSFET, I can do that very easily, but what I'm finding is that when the MOSFETs explode, it also kind of takes down the ESC as well. So even though I can replace the MOSFET, the board is damaged. And so I got another board and damaged it right away. So I started thinking, let me see if I can add some protection to this, because it doesn't look like it has current protection. It certainly doesn't have out of bounds or anything like that. So the first step is to add current sensing to it. So in this case, I don't have propellers added. The left side is dead. The left side is not even connected. The right side will spin. And so what I've done is I took a board that I use on other motor systems, which has a MOSFET on it that I can turn on and off the battery. I'm using a bench power supply right now. I'm not using a battery. The battery's here disconnected, but I'm running 22 volts into this controller, which has a MOSFET that I can turn on and off the drone with. And then I have a current sensor resistor on here, which lets me monitor the current. And then there's a current sensing chip that goes to an op amp, which goes to a comparator, and the comparator lets me turn a set screw. Like here, I can turn this set screw and set a threshold voltage from 0 to 3 volts and set a threshold for where I want the motors to shut off, and that would represent an overcurrent situation. So let me see if I can spin up the drone. Okay, I've got two motors spinning here, left on the right side. Left side's dead. Okay, now on the scope is connected to the output of the 393, which is the final output of the current sensing. Okay, so this is where the voltage from here would go to a microprocessor, and in my case, this is what I'm going to build, a microprocessor board that will live up under the drone. So I'll put this and Velcro it or some method to attach that under the drone. And so you'll have the voltage coming from the current sensing trip, and I've got it going to the scope right now. So if I grab a motor, you can see that shows me overcurrent. All right, so I can grab the front motor or the back one. And now you can see that's an overcurrent, which is a voltage or a threshold that it's tripping at based on where I set this trim pot. So in this case, it's not set to anything that would really fly. If I speed it up, you can see I'm tripping it as well. So this would have to be set based on what would be above a normal flying condition. So if you set this to a certain threshold, it would have to be above what your normal flying conditions would be. And there's ways to do that so that you can test the drone. And I will have some LEDs on the board that will let me safely see, hey, I went over my threshold. And then with a button, I will be able to increase the threshold while it's flying. So I can go bump, 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 increase the threshold for the trip, and then I can reset the LED. I can fly it aggressively, fly the drone as aggressively as I can to try to get it to trip. And if I can get it to trip, then that means I don't have enough threshold. So then I increase the threshold more. And once I get to a point where I don't get any trips, then I know I can fly the drone, and normal flying will not trip the threshold. And if you do trip the threshold, what will happen is it will simply disconnect the battery, because the battery is going through a MOSFET here. And so the battery will be connected through a module that connects to a board that interfaces between the battery and the back of the drone. Right now I've just got test leads. That little module will look like an XT60 module. For some people buy them for calling smoke proof or a pop proof or anti-spark, whatever. I'll have that on there as well, but that's a trivial detail. Okay, so let's take a look at some data. I've got some test leads here. The logic analyzer going. I ran some wires into the drone, so you can see here I'm going to some connectors in here. One is for telemetry, so I've got a bit stream or a byte, some bytes coming out of there. 3 separate sets of bytes, low and high, that I can monitor. And I also have the S-bus coming out. So I've got 2 wires coming out. One is telemetry and one is the S-bus. The S-bus shows me what is being sent from the buttons, so that I can actually program a button here, get the data onto a wire, run it into my microprocessor here, and then convert that button to do something. So in other words, I could make a button like, for example, I could say arm the protection mode or turn off the protection mode. So in other words, protection mode means overcurrent shutdown, out of bounds shutdown, upside down shutdown. I can turn off the protection just by flipping a switch, because now I can take the data that's coming from the switch, see it on the screen, convert that through the microprocessor to real world turning things on and off. So roll is if the drone's facing front, roll is one way or the other. So in my case, if you roll the drone, here's the front of the drone. If you roll it this way, rolling right, roll it this way, rolling left. Okay, tilt is tilting down or tilting up. Okay, yaw, depending on your definition, right, left. We could also call this heading. And so in my situation, I can dissect and reverse engineer and find the data for right, left, tilt down, tilt up, and orientation. So in other words, facing this direction, we're at about 0, and I can do 360 and see the data on the screen. So here I have written down what I have extrapolated from the data stream. So you have a high byte and a low byte, meaning you've got 16 bits of information per axis. Okay, let's call it roll axis and tilt axis. So if you look here, I have marked on the screen roll. Right here, roll, low byte, high byte, and directly below it, you can see it's sitting at 62 and 0. Now, if I take the drone and roll it to the left, you can see that the numbers change to 255, 254, 253. Those are negative numbers, okay? Above 0, I'm going to rotate it to the right. Now we're at 0, 1, 2, 3, 4. And I can rotate the drone all the way up to, let's call that 90 degrees. And now we're at 29 on the high byte and rolling it all the way to the left 90 degrees. Roll is at 224, okay? So with that information, I can then have that information go to the microprocessor here through the wires out of the drone on the connector on the bottom. These connectors are actually on the bottom of the drone where I'm tapping into that with a JST connector. Run to the microprocessor. Then I can set some thresholds to say, if the drone goes more than 90 degrees or whatever I want to put it at, I can decide what that number would be. Shut down the battery, kill the battery. Because on this drone should never be more than 90 degrees, but I could set it for 100 degrees or 110, which really means the drone has flipped upside down. So the same thing goes for tilt. So here I'm on tilt, low byte, high byte, corresponding Right below it here, we've got high bite 1, high bites 1, low bites 96. So if I tilt down, where it tilt, you can see it change from, I'm gonna do it slowly. Let's say we're at 0, which is basically flat, or sitting on 1. That's 0. Now, 255 is a negative number. And the more it goes down, that means it's going negative. Tilting down is negative on this drone, okay? Now, if I tilt it up, you can see there's tilt. And above 0, let's start at 0. Let me get it to focus. There's 0. Tilt, high bite. 1, 2, 3, 4. The more I go up, if I go up to 90 degrees like this, you can see that the tilt is now at 32. If I go more, you can see it continues to climb. Okay, tilting down, 240. I know this is difficult to hold a camera and do this at the same time. Tilt back to, okay, so now we have the yaw. We could call it yaw, we could call it orientation or heading. I think I called it heading on here. So heading is our, let's call it compass. It's not true north, but here we have some digits here, low bite and high bite. So the high bite is going to be the biggest value out of the two. So if I rotate the drone, you can see that the number is going down. 47, 46, 44, 43, 40. If I go back the other way, 100, 102, 105. And you can see that as I'm turning the drone, rotating it this way, that value changes. Now, there doesn't appear to be a z-axis or a some type of method to determine that the drone is upside down, other than looking at your roll and tilt. And it's very easy to take those numbers, and if either one of those numbers is out of bounds, meaning greater than what the drone should normally roll. In this case, this is not an acrobatic drone. I can't even make it do a flip that I'm aware of. So roll bite, tilt bite, heading bite. In my case, I can take roll and tilt, and if one of those is out of bounds based on a threshold that I set, where I can say, if roll exceeds this way 90 degrees or exceeds this way 90 degrees, or if tilt exceeds this way 90 or that way 90, then that means this drone is probably hit something and is in an unrecoverable state. Like I hit a tree and it tumbled out of the tree and the motor stopped and burned up the MOSFETs while it was tangled in the tree, okay? So the goal is two things. One, kill the motors, kill the battery immediately when a motor senses more stress than it would in real world flying, okay? Also, kill the motors if the drone is in an orientation that is not standard. In my case, I've seen drones that will do flips and flip upside down. So if you've got a drone like that, or if I had a drone like that, then certainly I couldn't leave it upside down. Now I can set a time to say if the drone's upside down for a certain amount of time, not in a case where maybe somebody's got a turtling drone and it can fly upside down extended time, but with normal props, this drone is not going to fly upside down for very long. And so I could set a timer to say, if the drone is out of bounds for a certain amount of milliseconds, then kill the power. Because if the drone is like this for 2 seconds, that is certainly bad, because there's no way it can fly like that with these type of props and with these type of motors. So the idea is to reverse engineer the data stream. I also have the data stream for the S-Bus. I've got that right here. I'm not going to show it, but what it does is it lets me see all of the buttons. I can see all of the joysticks. I can see this button, this button, this button, this button. Switches. Here, you've got a 3-position toggle here. The 3-position here, but this one's already allocated to GPS mode or altitude hold or return home. And I believe this one's not assigned to anything. So what I'm going to do is assign this to no protection, protection in the middle, or possibly a mode to kill the battery anyway. If I were to hold down a button, pull it to the right, I could put the drone into a state to go ahead and kill the battery. That way, if I know it's crashing, or if I know it's over a body of water or something like that, and I know it's going down, I can kill the battery and hopefully try to save some boards. And in my case, I'm on my second board now. I'm waiting for the third one to show up. And hopefully, I'm going to add some basic current sensing to the next version so that if I crash it, which probably will, granted I was doing some dumb stuff before. The first time I got the drone, I'd never flown a drone before. It got in late at night and I decided to fly it in the dark. And I couldn't even see it anymore. It crashed into a tree, crashed to a tree. The second time I tied a rope to the bottom because I wanted to test what would happen if I turned off the power to the G12, assuming that it would return to home or return to the launch position, but I didn't want to gamble on it, so I tied a rope to the bottom and of course caught the rope on something and flipped the drone over. So, all right, I hope that you enjoyed this scattered video, but this is some stuff that I want to discuss. If anybody has any comments, please chime in. Thanks.